This is the entire process I do to rebuild a torque converter. Now this torque converter here came out of a Lexus LS430. I rebuilt the transmission on it, but now I gotta see if there's any problems inside the converter. To cut this thing open, we're gonna use an old lathe to turn it as we push a blade into it. We're looking to cut all the weld out of the crease where the two plates meet. Layer by layer, we peel back this converter kind of like an onion. And once we get it peeled back to where we think it's close, we give it some love taps with a hammer. And if we've cut enough weld off of it, it will break free, but if not, we have to keep cutting. Eventually, it'll come apart, and sometimes you have to beat it up a little. Now we can check out the inside. Now each of these parts has a very important function. Basically the hub and the front impeller. And what I mean by impeller is this system right here. So this is basically a fan that attaches to the engine. The main job of this front impeller is to provide power from the engine to the turbine right here, which spins the transmission input shaft. Now the front impeller not only drives the turbine, but it also drives the transmission pump as well via the hub. Now next is the stator, and its job is to only turn one way and create extra fluid flow between the impeller and the turbine, which makes the converter a whole lot more efficient. Now we have our turbine, which provides power to the input shaft of the transmission, or in other words, the main driving power of the car. And it gets fluid sent through it from the front impeller, which turns it and turns the input shaft. And last but certainly not least, we have our torque converter clutch, which is the main cause of failure in most torque converters. Its job is to provide efficiency between the engine and transmission at higher speeds, and it does this by splining into the turbine and locking up with the back of the converter at highway speed. At about 45 miles an hour, this clutch will get applied onto the back cover, which is attached to the engine, and make the turbine a 1-to-1 grab with the engine, sending a 1-to-1 ratio from the engine to the transmission input shaft, which dramatically increases engine efficiency, especially at higher speeds, which will save gas and hopefully eventually save the planet. So how does this system work? Well, let's picture two fans here. Now one fan is our front impeller that's attached to the engine because of the weld to the back cover, which is bolted to the engine. Now this other one is free spinning inside the torque converter. That's our turbine. It's attached to our transmission input shaft. So front impeller, turbine, engine, transmission. Now when you turn your engine on, it'll turn the front impeller, which will blow fluid into the turbine, which will turn the turbine. Now the faster you spin the engine, the faster the turbine will spin. Now what's really cool about this system is if I stick something in here, like a brake on a wheel to stop the turbine, it'll stop. So this is your car at a red light, and this is your car when you let off the brake. And as you see, this fan is not plugged up. So this is just energy transfer through fluid or air from the front impeller or engine to the transmission or turbine. And when we turn the engine off, everything will stop. So that's how the torque converter turns engine RPMs into transmission torque. And you can see it work. As you spin the whole converter, the turbine will spin as well. Now the problem with this whole system is it becomes incredibly inefficient, especially at highway speeds, and that's why you got the torque converter clutch that'll lock up to the back of the converter and turn this turbine into a 1-to-1 ratio with the engine, which is a whole lot more efficient than two fan blades powering your car. But this works great for takeoff. Now the torque converter clutch is a pretty neat piece of technology that makes your car a whole lot more efficient, but with better technology can come more problems. And when these torque converter clutches start to degrade, they'll start flaking off the clutch plate, which can clog up your transmission filter and will leave you sitting on the side of the road. And the clutch in our torque converter was a little like Aaron Rodgers in the playoffs. It was a little flaky. Now we don't want that to happen to our freshly built transmission, so this flaky clutch has got to go. And we have two options to fix it. We can either cut open another torque converter and hopefully it'll have a good clutch, or we could cut the clutch off of this plate and try to rebond a new clutch. Now for this torque converter here, I had another one in the shop. We cut it open and we found a pretty decent clutch inside of it, so we decided to use that one. But if we were to rebond it, we need to put it in this machine that heats heats a top and bottom plate up to 400 plus degrees, presses it together to bond a new clutch to this plate. Now there's a lot of machining and a lot of work that goes into doing this, so finding another clutch and another torque converter will save us a lot of time. Now before we put this converter back together, there's a couple things we got to do. First of all, there's two seals that we have to change inside this converter. One is an input shaft seal, and the other is the seal for the actual torque converter clutch. Now to get these things back together perfectly, we have to machine both the back cover and the front hub and impeller. Now the reason we have to do this is because the back cover and the front hub have to sandwich together perfectly and be able to tuck in nicely where we could set the clearance for the clutch and the bearings inside. Now we also do some machining on the outside of the front hub and the outside of the back cover. Now this is to make the sandwich between the two exactly perfect when we get it on our turntable machine. This helps us set the run out, and the run out is how perfectly this thing is welded together and how perfectly it's going to spin once we get it back in the car. Picture a stick going straight through the middle of the converter, and if the run out's perfect, that stick will be completely straight. If the run out's a little crooked, then that stick's going to be a little crooked. Now we use a special machine to weld this together, and we bought this from a company out of Baltimore called ATI, and they still make this equipment if you're interested in it, but it's really expensive. We use a heavy-duty Miller welder to weld these things together, and we take 3 spot welds on the outside of the converter before we lay a nice thick bead. 3, 2, 1. Now this machine comes with an auto weld feature, so all I got to do is set the torch, flip a switch, start turning the converter, and press a button. And it'll weld all the way around, and once it gets to the end, I have to pay attention and turn the switch off, which will stop the welding process. Now once this thing is welded together, we have to check 2 things. 1, the run out, and 2, we have to make sure it doesn't leak. Now the run out is pretty easy to check. We just leave it on the turntable, and basically we're seeing how out of round the pilot is with the hub. And we use a little dial indicator to see how many thousandths we're off. And anything under 10 thousandths is great. Anything over 15 to 20 is really bad. Now this thing had a run out of 6, which is amazing. That means we did a really good job machining this thing, and it's going to run really smooth in the car. Right there. It's a pretty bad one too. Our leak test didn't go so well, and that's because these Toyota converters can be a little tricky to weld together. Sometimes you got to cut them back a couple times to get them completely to bond together, and that's what we had to do on this one. And in fact, we ended up welding it 3 times before we got it to not leak at all. Now we got a completely together torque converter with a brand new torque converter clutch, new seals inside of it. It's completely cleaned out, welded together, and completely leak tested, ready for install. Thanks for watching, and whatever you do, however you do it, make sure you work hard, make sure you play hard, and most importantly, make sure you stay dirty. You could just call me Eddie.